Okay, so we've got an integral here. We're just trying to integrate 3 divided by x squared plus 1/9 with respect to x. Now, there's some sort of relationship here between the 3 and the 1/9 and the x squared, but I'm not sure what that is yet. So I'm just going to do some simplification here and see what we can come across. So let's just change this integral up a little bit now. And now I'm going to take the 3 out front, and that's going to leave me with 1 over x squared plus 1 over 9 dx. Okay, now this is looking like an arctangent kind of situation. We've got an x squared plus a square number. So 1 over 9, what's the square root of 1 over 9? So square root of 1 over 9, that's the same as the square root of 1 over the square root of 9, which is 1 over 3. So with the inverse tangent in mind, I'm going to try and do that, because if you try to do partial fractions of this, that's going to look quite a mess. So let's just try and write that as 1/3 squared. So now we've got 3 times the integral of 1 over x squared plus 1 over 3 all squared dx. Okay, now the 3 and the 1/3, we can't do anything here multiplying by 3 to cancel out this 1/3. That's not going to work, that's not legitimate. But what we could do is, we've got an x squared here and we've got a third here. So if we try and substitute something in with the reciprocal of this times this square root of this, we have some sort of chance of getting the inverse tangent. And this 3 at the moment, I'm just going to leave out front and just ignore it for now. So let's do a u substitution. So now u, will let that equal 3x. So let's do that. So let's try plugging that in and see what happens. Before we do that, we need to find the derivative. So du equals 3 dx. So now my dx equals du over 3. So now I've got all my stuff ready now for my u substitution. So now I've got 3 times the integral of 1. Okay, x squared. Now u equals 3x. So I just need to change that up a little bit. So now my x equals u over 3. Now that's the format I want for my x squared, because if I try and do it from this, I can't just plug in u squared, that's not going to work. U squared is 9x squared, where here I've got x squared. So x equals u over 3. So now let's plug that in. So u over 3 squared plus 1 over 3 squared. And now my du is 3 dx. So dx equals du over 3. So now I've got du over 3. Okay, now we're in with a little bit of luck here. I've got this 3 here and I've got this 3 here. I can now take that out. So that's good. So they can now cancel each other out. Okay, now what about u over 3 squared and third squared? Let's just try and simplify that out a little bit. So now I've got 1 over u squared over 9 plus 1/3 squared, which is 1 over 9. And then that's just du. Okay, now if I multiply by 9 on the top and bottom, so if I just change this du a little bit to give me a little bit of space. So now if I times this by 9 over 9, just put my du back in, all I'm doing now is multiplying up by 1. So that is fully legitimate, because I'm not changing the value if I multiply by 1. So now my 9 here will now go on to the top. So I've got 1 times 9 on the top, and then this 9 in the denominator will cancel out both of these 9s. Because now what I could do is, if I just write that out up here, so let's make a bit of space. So what I can do is, can rewrite my integral as 1 over 1/9 times u squared plus 1, and then I've got my 9 over 9 du. So now you can see there now the 9 and the 1/9 just become 1. So this and this cancel out. So now I'm left with 9 over u squared plus 1 du. So take this off here now. Bring the 9 out the front. So now I've got 9 times 1 over u squared plus 1 du. Now integrating this, that's just straightforward inverse tangent. So 9, so I'm going to write this now as arctan. A lot of people keep asking me to write arctangent rather than inverse tangent. So they like to see that. So there we go, there's an example. 9 arctangent and then u. Okay. So now we've got 9 arctangent of u, and we're still not ready. We've got a couple of steps just to go. We need to plug in our u, which is 3x, and then don't forget the plus c. So 9 arctan of 3x plus c. And that is my finished integral. Okay.